Good afternoon, my dear student. Yes, in our previous class, we have discussed a lot of example on the continuity. So now we will go to another most important concept, differentiability. So I would like to discuss in front of you that is the most important concept in the form of derivative you have studied in the first year. That same things we are going to expand the terms. We are going to express for the differentiability. It means reducing the values. Another most important concept in every concept will be most important. Let us discuss one by one. What do you mean by differentiability? Already we have defined for the continuity like that. Suppose f is a real function on a subset of real number and let C be the point on the domain. Then there exists some point. It means there exists for the limit h tends to 0 f of c plus h minus f of c divided by h. This is called the differentiability. Suppose f is a real function on a subset of real number and c be the domain of the function, limit h tends to 0 f of c plus h minus f of c divided by h. Hence required equation. So in this one, lot of formulas are there. These are the first I would like to discuss basic formulas one by one. Then later we are going to discuss most important concept. We will go to deals with that. So now let us consider the definition with formulas. So what do you mean by differentiability? Right? Suppose f is a real. Suppose f is a real function subset on a real number and let C be a points on domain, and then there exist limit, right? Then there exist limits. So this point, limits of f. What do you mean by limit h tends to 0 f of c plus h minus f of c divided by h. Hence require f dash of c is equal to, function will be there, limit h tends to 0 f of c plus h minus f of c divided by h. Hence required equation. Or you can express function f of x, f dash of x. Here c is the, here x I can consider, limit h tends to, not h, you can take h tends to 0 f of x plus h minus f of x divided by h. This is the in the form of x variable, in the form of c variable. So these are the definitions of the differentiability. Now I'm going to discuss problems, formulas first. Then later we are going to discuss the problems, right? So next, keep all these values. All these are most important things, right? Formulas. First one, differentiation of dx, constant. Constant means every numbers. Differentiation of any numbers. For example, differentiation of 1 dx 0, right? Second function, differentiation of dx x to the power n. So n x to the power n minus 1. I can take another one, differentiation of dx x to the power square is there. So 2, it goes to value 2 minus 1. So next third one, dx by dx, it means 1. Fifth, differentiation of dx, e to the power x, e to the power x. So here differentiation of e to the power minus x dx, e to the power minus x. So here differentiation of log x dx, so 1 by x. So you can carry for the values, so we can express next one, 8, differentiation of dx. So here log x is there, you can take any values. I can take constant to the power x, ax log a, right? So next differentiation of dx, root x, 1 divided by 2 root x differentiation, right? So next we are going to express any different type of numbers, you can put it here. So 10, differentiation of dx, sine x, trigonometric function, differentiation of trigonometric function, cos x. So differentiation of dx, cos x, so minus sine x. 12th, differentiation of dx, tan x. So here second square x, right? So 13th, differentiation of dx, sec x. So here sec x tan x, right? Here differentiation of cot x minus cosecant square x. Next differentiation of dx, cosec x minus cosec x cot x, right? So next differentiation of dx, sine inverse trigonometric function. These are the trigonometric function and inverse trigonometric function. What are this one? So 1 divided by root of 1 minus x square. So differentiation of dx, cos inverse x minus, right, 1 minus x square. So differentiation of dx, tan inverse x, 1 divided by 1 plus x square, right? So next we are going to represent differentiation of dx, 19th, right? What are the differentiation of cot inverse x minus 1 divided by 1 plus x square. So 20th, differentiation of dx, sec inverse x. So 1 divided by x root of x square minus 1. So 21, differentiation of dx, cosec inverse x. Minimum knowledge, minimum must and should everyone perfect ಎಲ್ಲರಿಗೂ. ಸೊ ಪರ್ಫೆಕ್ಟ್ ಆಗಲೇಬೇಕು ಈ ಫಾರ್ಮುಲಾಗಳನ್ನು. ಸೊ ನೆಕ್ಸ್ಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರೈಟ್ product rule, product or Leibniz rule, right? One of the greatest person in a mathematician has given wonderful formula. So differentiation of uv dx, uv, so u keep constant, dv by dx, v constant, du by dx. So this is the values. So 23, so quotient rule, right? Or you can say that rational rules also. It is a quotient, best word. Differentiation of u by v dx. Which terms is the denominator? First write that terms. So du by dx minus, so u dv by dx whole divided by v square, right? So next one, most important, chain rules, right? Chain rule in this two types are there, ds by d theta, ds by dt into dt by d theta get cancelled, so should be remains same terms. So ds by d theta, so we can express ds by d theta, dt, right? Here d theta by dt. This is the product chain rule, this is the quotient chain rule. Hence, these are the minimum formula you must and should perfect. Look at these fractions of second, you have everyone must and should perfect, then easy for the ever big concept, very easiest. So very properly we can simplify easily, everyone must and should perfect, keep in your mind. So you can take a small notebook and write down, and every time you are seeing, or otherwise you can put on a wall in your home or your room, whatever that big chart, make it and stitch it, then easy for remember, every day you can recall that one. Thank you, and I will go to some problems on this base, right? Shall I rub this one? I will go to next, some problems are there, we can express for the values. These are the formula, right? So question, find the derivative of tan 2x plus 3. One question is there. So many times they are asking question tan 2x plus 3. Sometimes they are asking sec 3 theta plus something, they are asking question. Then only first I will go to simple problems, then next I will go to different type of problems are there. Very easy formula. So keep that one. Solution given y is equal to, consider y function. What is the function? Tan 2x plus 3. A simple method. Try to understand. Already you know that. What is the formula? Differentiation of dx tan x. Here second square x. But here x replace the big function is the. Then again differentiation of 2x plus 3 dx. So why I am consider this one? Do you know that? So differentiation of dx, right? So you can express first formulas. This is a we are writing differentiation with respect to x. Here independent variable, then I can consider the x independent variable. So dy dependent, dx independent. So here differentiation dx tan 2x plus 3, then dot differentiation of dx 2x plus 3. Why I am writing this one? By using chain rule, right? Catch this one, how to make it that values. So dy by dx differentiation of tan second square 2x plus 3, right? This differentiation keep 2 outside, dx by dx differentiation of 3 dx, right? So already I can given the formula, it is a 1, differentiation of 3 dx is 0 because constant, any constant terms I have given the formula. So then only you can write dy by dx second square 2x plus 3. So this is the 2 and 1 plus 0. So finally dy by dx, 1 marks question, 2 second square 2x plus 3. You make it a direct solve, direct step, there is no problem. So this type of questions will be arises, keep in your mind. Next, this type of problems are there in your whole part. I will go to discuss. Try to understand, perfect the formula along with the differentiability and everything. So product rule, quotient rule, chain rule, and so many trigonometry, inverse trigonometry, and constant function. So I will go to the defining for the some other formulas. I will go to discuss. Any doubts are there, please send our YouTube channel or our WhatsApp number is there. So 8050 So keep in your mind, please encourage this. Please look at all these peoples and encourage for ourselves. Thank you so much. I will continue the next video.